Okay. Our next talk is by Erik Hazelton from SUNY ESF, and he's going to speak to us about walleye population recovery in an urban lake.
All right, thank you for that introduction. And again, my name is Erik Hazelton, second year master's student under Dr. Nero Ringler, and I spent my field season May through December studying Onondaga Lake walleye. Can you guys see me okay in the back? All right. So we're all pretty familiar with walleye, popular sports fish, ranging across the United States, especially here in upstate New York. And so I'll just give you a brief snapshot of the life history. Walleye, spring spawners, they like rocky shoals and lakes or rocky bottoms and tributaries of high flow. Light sensitive, they do a lot of their work at night, prefer cooler waters, and they're documented to migrate extensively to spawning ranges, and then also when they're done spawning, they tend to return back to a defined home range. So where are we? If you look up here in the map, this is upstate New York, and the black circle, it zooms into the slide here. So the study site is Onondaga Lake, and brief history on the lake. It's a super fun site. Most of you are probably familiar with it. It's had a long history of cultivation, of direct inputs of pollutants, high mercury levels in fish, and it's a current super fun site. Walleye inhabit Onondaga Lake, and like I said about their ability to migrate, they have the ability to leave and enter that system and move throughout this watershed. And Onondaga Lake is just north of the Finger Lakes here, but it's connected to Cross Lake via the Seneca River and Oneida Lake via the canal and also the Oswego River. So a little bit more about specifically Onondaga Lake walleye. We haven't seen spawning for decades. There's multiple other organizations on the lake that have been doing trawls for larvae and sampling like we do on the boat for the Biomonitor project, and there hasn't been any larvae fish found. But they're the most abundant fish in our gill nets. We set gill nets monthly through the field season. We've been setting these gill nets for the last 20 years. And in the most recent years, in our 5-inch stretch gill nets, we've been catching tons of walleye, big walleye. We've also done a number of telemetry studies. We've been tagging, here are the numbers back here for the last 2 telemetry studies. We've been tagging walleye, tracking the movement within the lake. And we've seen the walleye moving around the lake plenty, but also they, from the telemetry data, we've seen that they tend to be residency here during the summer and the fall. So it's in a sense, it's a closed population during that time. But we do see them leave during the springtime to go and spawn. And in following years, we sometimes don't see them return, and we don't know if that's because they merely just don't return that following year, or because they might have died on their trip. So why is this all important? Well, there's uninformed anglers in the region. You saw the map and the potential for these walleye to move. Oneida Lake is known as a pretty pristine fishery for walleye, and so people don't know that these walleye might have contaminants within them because of their ability to migrate so extensively. Also, the major modifications at the Superfund site are pretty much wrapping up. This year is actually the year they're scheduled to end the Superfund site, so it's actually an exciting time to be studying the lake. Things are starting to change. It's moving from fixing the problem to now adding more habitat and studying the changes in the fish community. So, exciting time. We're actually seeing some of the contaminant levels in fishes decrease to the point that some centroids you can actually keep now in the lake, but walleye, the mercury levels have decreased, but they're not, you don't want to keep any yet. And so, but in the future, we do want to plan for an urban fishery, and so we do want to know where is the source of these fish coming from. If they're not spawning here, they're coming in and using the lake, so if we want to manage the future, we need to know that question. So, 2 objectives to break down. One, we want to characterize the population. So, understanding, are they all, is majority males, majority females? How big are these fish overall? So things of that nature for the first objective. And then secondly, we also want, using a marking and capture study, we want to know how many fish are in this lake, how many fish are using Onondaga Lake during the season. Here's one of the smaller fish we've seen. So how do we try to answer these questions? So I mentioned earlier before we had 5-inch stretch gill nets, and they tend to target just big fish, or that's what we thought. So we decided to buy some experimental nets here. This diagram I made just sort of breaks it down. 4 different mesh sizes from 5 to 2 inches, and then we split it in half, so half of it's in the deep end, and then the other half is in the shallow end. And these are all bottom set gill nets. We did 30-minute sets in the cooler months to reduce mortality, and 15-minute sets in the even warmer months to try to reduce mortality, because gill nets do cause stress to fish, and low DO levels tend to occur in July and August. We did 10 sites per month around the lake, and so we tried to get a total of an hour of gill netting at each site per month. So in July and August, we would do 4 15-minute sets. And then when we got the fish, we obviously did the total length and the weight. So then I mentioned we're doing tagging. We decided to follow the New York State DEC method for jaw tagging walleye in Lake Erie. Here you can see a jaw tag right here on a walleye caught in Onondaga Lake. We have 3 different categories. What you need to take away from this is we just tend to put the jaw tag on the mandible of the fish, so on the jaw of the smallest fish, and this is a little bit of a bigger fish, so we put this jaw tag on the max. We double tagged 33 fish to measure the retention rates, and then we also inspected them for ventral fin flips. So every year that they do an egg take in Oneida Lake, they do different fin flips to mark that year's class coming in when they do the egg take. So this particular fin flip is a half left ventral. You can see some regrowth there, and this was caught in Onondaga Lake. So we're looking for both jaw tags and fin flips. So unfortunately, some fish did perish. All these numbers here on the right indicate the things we did for the number of fish we had. So we determined the sex of the fish, looked at stomach contents, see if they're eating anything unique, removed some visceral fat to check out some of the condition of the fish, checked the oldest for aging, and we donated 25 fish like we do every year for the biomonitoring to check fillets, contaminant levels, and things like that. So more methods, looking at our aging, we took scales from the majority of the fish that we handled, and we pressed them like we would usually do. And then we also extracted the oldest for every fish we could. We saw them transversely and then polished them and looked at them under the scope. And this is one of our oldest we aged to age 6, counting all the bands here. And then we tried to measure the population. So we decided to go with the schnabels to start because given what we've hypothesized, what the data has seen with the walleye in Onondaga Lake, that they tend to be stationary in the lake through May and the fall. And so we went with the schnabels because it's a close population estimate. Now moving into results. So these are 3 different types of gill nets that are set in Onondaga Lake every field season. Experimental nets were the newest ones that we added this last year. Sturgeon nets we're not going to talk about because it didn't yield too many walleye, but we still did catch big ones in sturgeon nets. Gill nets, these are the ones we set every year. We got 3 walleye per hour and a total of just over 150 walleye. More soak time for the experimental nets. We ended up catching 3.5 walleye per hour, and we ended up getting 360 total walleye in just experimental nets. So 518 walleye were handled in the study. Pretty good range from just under 300 millimeters to just over 700, and this is a 704 millimeter walleye here. That was the biggest one we caught all season long. Mean length just under 530 millimeters, and a mean weight just under 2 kilograms. And I added this photo here of one of the smaller walleye, but it was really fat. And this is sort of the walleye we can see. It looked like, just from observation, good condition and full of fat. Looking at some of the gill net data from the last few years, this is 2008 to 2015, and this is just the 5-inch stretch gill nets. This just shows it's a box whisker plot of the mean length of walleye caught in the gill nets. And you can see pretty much straight across the board here, there's really no difference in the size, and that these nets are essentially selecting for a certain size range of walleye. You add in the 2016 experimental nets that we used, we have a significantly different mean length here, 511, about 50 millimeters smaller than the average you see with 5-inch stretch gill nets. Just to break that down a little further, we split up the nets on this length frequency chart here. So the gray is your experimental nets, the ones from this year, and then your 5-inch stretch gill nets here in black. You can see again that they're selecting for the bigger fish here than the 5-inch stretch gill nets. While the experimental nets, you see a broad range of sizes going across the board, more of a normal distribution. We're starting to find small individuals of walleye than we've seen in the past. Going into diets, so we tried to look at the stomach contents of every fish. Most of the time there wasn't anything in the stomach contents, and from observation, we feel like they were expelling most of them in the gill nets due to stress, or when we were jaw tagging them, we had to dodge a few stomach contents while doing that as well. So not a lot of interesting information. We were looking to see if they're eating gobies, and we didn't find that. It was always pelagic, either gizzard shad or yellow. Pretty good even spread of male to female, and we feel like our gender identification was fairly accurate because we had the females being larger than the males and weighing heavier, just like they do normally. For this age frequency chart, what I want you guys to take away from here is it does not start at age 0, it starts at age 3, and it goes all the way to age 18. So we have not seen any young fish below the age of 3. Average age for the walleye entering the lake is 8.5. Some more results. Scrabble Creek is one of the most popular, or I think right now, the last few years, it's been where they're doing the egg tapes in Oneida Lake. And this is what we found for the fin clips. It makes up less than 1% of the total fish we encountered, but we saw 12 walleye that had fin clips. So this one here again is a half left ventral fin clip. So if you look here, these two dates correspond to when it could have been clipped. So this walleye probably was clipped in 2016 because you don't see any reef growth here. So this has potential to be either from 2016 or 2005. And now looking at the numbers of walleye we ended up estimating. So we ended up putting back 374 tagged fish and had a total of 27 recaptures. This yielded a population estimate of 2,800 fish with a very low variance in standard area, and about 100 or 1,000 spread between the lower confidence interval and upper confidence interval from the population estimate. So we feel like it's a pretty good estimate there. So trying to think about this a little more. Well, looking back at the experimental nets and comparing those to the 5-inch stretch gill nets, we do see that we're starting to see the actual picture of walleye in the lake. It's not just the big fish moving into here from somewhere else. We do know that there are smaller fish in the system based on our findings with the new nets. We're really hoping to get more of these jaw tags caught either within Onondaga Lake, within the river, or outside the system in general, and get angler reports. We actually did get our first angler report this past November. We got a jaw tag caught in Chapman Park in Oneida Lake, and he called in the tag. So we're hoping to get more. Unfortunately, these tags are a little hard to see sometimes, and one of our graduate students on the lake this year, I wasn't on the boat, accidentally donated this fish to the lab for contaminant analysis, and I got a call from the lab saying, we have a recapture here, so this was our first recapture of the season. So it didn't, unfortunately, think it would be put back in the lake. But based on our findings so far, we do know there's at least an exchange with the Oneida Lake based on the fin clips we've had, and then also the call-ins from the jaw tags. And based on the telemetry data that a graduate student in our lab has done before, we've had a couple of his tags called in, even all the way up into Fish Creek on the far end of Oneida Lake, a model of Fish Creek to be exact. So these walleye are moving. And moving on from that, just looking to some future work, obviously a Schnabel's close population estimate for the system isn't perfect, so we're going to be looking into doing some open population estimates to compare and contrast what we find with that. We're going to go out in the spring, hopefully, try to catch them on the spawning runs around the area, see if we can find some of these tags based on shocking data. And then looking into OLED chemistry, Karin Lindbergh's on my committee, so she'll be able to help me a lot with this, and we'll be able to use the OLEDs to tell us certain things that just the jaw tags and the length and weight of the walleye won't be able to tell us. So maybe we'll be able to see, are these fish raised in a hatchery, or is there a chemical signature that can tell us how much time they're spending in a certain area. So that's the goals from that. We have 2 right now that have gone through the laser, and so we're hoping to get some data soon, and I'll be adding about 25 more of those. I would like to acknowledge my committee, the graduate students who have helped me out, all the technicians that we're so lucky to have in the lab, and Honeywell and Parsons for providing funding, and obviously ESF for furthering my education. And with that, I'll take any questions.
Do we have time for questions?
Have you had any angry fishermen come up to you while you were gill netting?
No, not really. I'm more or less angry at them when they're driving into our gill net and then getting their fishing line caught on the gill net because they think they're going to catch the fish. Yeah.
Are you checking the overlist for OTC runs?
No, that's not. I'm not sure if the OLEDs do have them within the region.
We actually do OPC market, Alameda.
You do?
Yes.
So, I mean,
And there's
that's,
a stock name also in the Central River.
Okay. Well, that's actually great to know. So that we will, yeah.